For x and y positive real numbers such that x plus y equals 1, the question is to prove this inequality. 1 plus 1 over x cubed times 1 plus 1 over y cubed is greater than or equal to 81. So how we will proceed? First of all, we will develop. We have this product is equal to 1 plus 1 over y cubed plus 1 over x cubed plus 1 over x cubed times 1 over y cubed. And here it's equal to, by rearranging, 1 plus 1 over x cubed plus 1 over y cubed plus 1 over xy cubed. And here we will use our inequality, which is x plus y squared is greater than or equal to 4xy. We will prove it. So to prove it, we just make the difference. We have x plus y squared minus 4xy is equal to, here we have a special product we develop. It's x squared plus 2xy plus y squared, the special product, minus 4xy. And this is equal to x squared plus 2xy minus 4xy and plus y squared. We just bring this term here. Now x squared and plus 2xy minus 4xy. It's of course minus 2xy and plus y squared. And here we see we have our special product x minus y squared. And since it is a square, it's surely non-negative. So we have the difference is non-negative. That means that our inequality holds. Now we will apply it here with our x and y. So since x plus y equals 1, we will have 1 squared is greater than or equal to 4xy. And here, I continue here. So I just divide by xy, which is a positive number. 1 squared is 1. And I divide by xy. I will have 1 over xy is greater than or equal to 4. Now I cube the two terms. I will have 1 over xy cubed, since the two terms are positive, is greater than or equal to 4 cubed, and 4 cubed is 64. So this term is just this one, 1 cubed over xy cubed. It's like this, which is greater than or equal to 4 cubed is 64. Now I have this term here. And now I will do the second term. But to do the second term, I will need another inequality. So what is this other inequality? First of all, I will write this one here. I have 1 over xy cubed is greater than or equal to 64, the first one. Now I will show you the second one that we will use. The second one is that for x and y positive numbers, we have x plus y is greater than or equal to 2 square root xy. And to prove it, we just make the difference as the previous example. So here we have x plus y minus 2 square root of xy. This number is equal to x is square root x squared. Here I supposed that x and y are positive numbers. So plus square root y squared minus 2 square root x square root y. And this is equal to square root x squared minus 2 square root x square root y plus square root y squared. And here you see it's again the special product x square root x minus square root y squared, which is, of course, this number is a non-negative number, and that means, since this number is a non-negative number, that means that again our inequality holds. Now this inequality will be applied for those two terms. So how we will do? Here we will take our x equal to 1 over x cubed, and our y will be 1 over y cubed. And this will be, applying this, is greater than or equal to 2 square root xy. Our x is this one and our y is this one. So 1 over x cubed times 1 over y cubed. And this means 1 over x cubed plus 1 over y cubed is greater than or equal to 2 square root 1 over xy cubed. Now here we have 1 over xy cubed is greater than or equal to 64. We have proved this, and we will, to get this, we will just square root the two terms. So what I will have, square root of 1 over xy cubed is greater than or equal to square root of 64. Square root of 64, and square root of 64, of course, is 8. Now I will continue here. I will have multiplying by 2 the two terms. I multiply by 2 here and here. I will have 2 square root of 1 over xy cubed is greater than, and now calculate with me, 2 times square root of 64. Square root of 64, this number is 8. So square root of 64 is 8. And 8 times 2. I multiply here by 2 and here by 2. And 8 multiplied by 2 is 16. And now, here we have the first inequality, and here we have the second inequality. Here, if we call this number to be A, and this number to be B, and this number to be C, we have A greater than B, and B greater than C. You see, from 1 and 2, we will have this number is greater than or equal to this number, because this number is greater than or equal to this one, and this one is greater than or equal to this one. So from 1 and 2, I will have 1 over x cubed plus 1 over y cubed is greater than or equal to 16. And now the final step is just to get this sum, which is this product. I will just sum the inequalities term to term. And I continue here. So I have, I have 1 plus, and this here 1 over xy cubed plus 1 over x cubed plus 1 over y cubed. Now this one is greater than 6 or equal to 64. So 1 is just a constant, we add it also here. And here, this one is greater or equal to 64. So we have 64 here. And this one is greater than or equal to 16. So I add here 16. Yes, like this. So I add here 16. You see, 1, this is 1, and here 1 over xy cubed, 64, and this term is greater than or equal to 16. And now, finally, I have just to calculate this number is just this product. And here, if you calculate, you will get 64 plus 16 is 80, 80 plus 1 is 81. And finally, you get to the conclusion, since this number is equal to this number, we have developed it, this number is equal to this number, we have proven that this number is greater than or equal to 81. And this concludes our problem.